This is the 2017 National 5 Maths Paper 2 question 13. We've got two identical shapes used to form a logo, and each shape is part of a circle. The full circle would be this, and we have a chord. The circles have centre C1 and C2. The radius of each is 14 centimetres. The logo has half-turn symmetry, and it's got 48, AB is 48 centimetres. Step 1 is we're going to sketch the shape as it appears, and we are then going to fill in any information we can find either on the diagram or in the question. So centre C1 and C2. The radius is 14. So the radius goes from the centre to a point, any point on the circumference. This is 14 centimetres. You do want to do a sketch in this because it's very hard. This question is very difficult, and it's even worse if you don't have a sketch. So you've got the two radii, or I think radii is the plural of radius. They're each 14, but this point is on the circumference of, if you imagine the full circle, so if you had a full circle, this would be, and this one, that point would be on the circumference of both of them. So this distance is also 14. And so is this one. We're getting a lot of information. And we have AB is 48. And the shape has half-turn symmetry. So that tells us that this distance and this distance, we'll do this one in blue. So the green distance is from A to the midpoint of AB. So the midpoint of AB is the point which the half-turn symmetry happens around. But we know this is the midpoint. So this is the midpoint. So the green distance has to be equal to the blue distance. And each of them are going to be half of 48. So this distance would be 24. And so is the green one. I'm going to just sketch one of these because it's getting a bit tight for space, and we don't need both of these now because they're both same dimensions. They're just again we have 14 and this to this is 24. So half of that chord is going to be 12. I'm going to half of this is 12. And it's a point of principle that if you have a perpendicular bisector, what I mean by a perpendicular bisector is it's going to go through the centre of the circle and it's going to be perpendicular, i.e. at right angles to the chord. In that case, this side is equal to half of the chord, making that distance 12. So if you get a question like this in an exam, you go from the centre and until it makes contact with the chord, perpendicular bisector, and it takes up half the distance of the chord. And we can then we're going to call this blue distance is x. If you have a look here, then this is x, but this is the same because of the half-turn symmetry. This also has to be x. And this is the height, denoted h. We have a look at this, that is the height. And the height comprises of this radius, this x, so that is the height of this first shape, then an x, then radius of 14. So we have the height h with height h equals 2 times the height of each shape, and each shape is 14 plus x. H equals 28 plus 2x centimetres. I recommend pausing the video and looking at that again if that didn't make much sense, but if you look at these diagrams, then you look at the height of this shape and the height of this one. But this is right angled and we have to find x. What are we going to use? Easy question, Pythagoras theorem. C is the hypotenuse and A and B are the shorter sides. The hypotenuse is always opposite the right angle and it's the longest side in the right angled triangle. It's 14. Make sure you don't find C because we know C. That's 14 squared equals, and we have A is 12 and B is x. So B is x. Although you could make A x, the point is x has to be one of the smaller sides, so that's A or B. and you're going to plug that into the calculator and find a value of x squared. So x squared is 52, and x is the square root of 52, and we're going to keep quite a lot of decimal places. You don't want to round off too early in a question, so 2, 1, 1, 1, 03. In fact, no, that's plenty. So 7.21110 centimetres. The height is dictated by 28 plus 2 times 7.21110. So what you have to do is plug that in to the calculator. And that would give you 42.42220. Remember, this is a calculator exam, so it would be hard to do this without a calculator, but you do want to use a calculator. And make sure to watch for BODMAS, because not all calculators are intelligent enough, so you have to watch for that yourself. There's no guidance on rounding, so we can round this off a bit because 5 decimal places is not needed. So I'm going to use 2 decimal places. So to 2 dp, the height is 42.42 centimetres, and that's us done this question. So let's have a look at how the SQA would award marks in this. Your first mark would be for this. A few things to note. You must include the right angle, or you must write 90 degrees here. You must put that, because otherwise you don't show the marker that you know that's a right angled triangle, and you need to show it's right angled because that's a prerequisite to use Pythagoras' theorem. This would be the first mark obtained through the sketch. The second mark would be for knowing to use Pythagoras. The third mark would be for finding x. And the last mark would be for finding the final answer. And here are the common mistakes that many pupils made. If you got the wrong sketch and you somehow got the correct method for Pythagoras, then they would then deduct another mark. And as I said, a common mistake was assuming that you're finding the hypotenuse, because x is not a hypotenuse. Many pupils substituted 24 instead of 12. So many pupils thought that this distance of 12 was actually 24. And number 3 is just even worse, because they assumed x was the hypotenuse and they substituted 24 instead of 12. So this third one is a total train wreck, so to speak. So I hope you found this video useful. I will show you the solutions one last time. But yeah, this was a challenging question. So best of luck with the studying.